Takara, what is this thing?
Well, it's a piece of acrylic. The brown paper that you kind of see is copper tape. And the copper tape, it basically gives you leeway so that you can measure the resistance wherever. It doesn't really have a purpose except that it has electricity flowing through it so that you can see on the voltmeter it's registering resistance regardless of where you are. The thing in the middle, the small device, is SMD, which is a service-mounted device known as a thermistor, which takes heat and converts it into resistance. So basically, the higher the temperature, the lower the resistance. And it's used in modern-day sprinklers so that the lower the resistance, which triggers a device, which is a sprinkler which turns on water.
So like a fire alarm kind of thing, or
basically.
Fire sprinkler?
Mm-hmm. So this is our project. The way that we're using it is the numerical values that basically we're gonna have it sense that if it's a low resistance, we're gonna have it power on the motors, which is gonna turn our device, which is gonna release water to put out the fire.
Now, how did you figure out how to make the thermistor work?
Well, we had 3 trials. One trial, we burnt some alligator clips and lost the thermistor. The second trial was we had alligator clips again, but we couldn't really like clip them on and hold it in place enough to have any, voltage or measurements. So
it's pretty small.
Yeah, it's really, really small. So we just decided to put it on a flat surface where we could just basically control where on it we could, record resistance. So that's basically the purpose of the copper tape. And we soldered it to a wire, which is this thing. You can even record resistance up here, which is just about the same as the copper tape, give or take. Basically, this connects to the GoGo board, which we're using to program our entire project.
And then how did you do the testing to figure out that it worked?
We went in different areas with different temperatures. Like, say if I put my finger on it, ask me, you want to put your finger on it? Yeah.
Right here?
Mm-hmm. If you put your finger on it, it's taking your body temperature. And like I said, the higher the temperature, the lower the resistance. You see it dropping. So we basically tested it. We went outside and it gave us a lower value than inside because it was a lot hotter outside. We went in the freezer and the resistance went up because the temperature dropped dramatically.
So I'm like 811.
So the number doesn't really mean anything until you assign a meaning to it, yeah?
Basically.
So we could take this and we could put it in the sun and it would have a different value.
Versus putting it in the freezer or outside or inside. So.
And how could you use that number in a program?
Basically, you can program around the number, saying if you desire something to go according to a low number, like low resistance, say in GoGo board, you'd say, wait until resistance is 8.0. And once it hits 8.0, you're gonna have to program it to trigger something. So you
Turns
say,
on a light, turns on a motor.
Motor on, and the motor will turn on according to what you program it to do.
All right. Anything you want to add about the thermistor and what it can do?
Nah, that's about it. Oh, the only reason as you can see, there's no solder in between it is because if we bridge the 2 copper strips, it'd take the resistance of just the solder, which is basically useless. So if we wanted just the resistance of the solder, we wouldn't have the thermistor there. So as you can see, I'm gonna try to just get the resistance of the solder, but yeah.
So that's the thermistor right now. Oh, so it's back up to temperature now.
Mm-hmm.
All right, thank you.
Yay.